Hello and welcome. This set of videos is some solutions to problems that are similar to problem set 7. It didn't count. Alright, so the themes are sort of continuing from last week with things with parametric motion and so people moving from one point in the coordinate plane to another, but it also kind of introduces, we're also looking at like quadratic modeling, so just equations of quadratic equations that are helpful for finding like a minimum or a maximum distance. So let's look at this one. This kind of combines things nicely of sort of what you learned in the last week in a few chapters. So Kyoki and Nalani are moving in the xy planes along straight lines at constant speeds. They both start at the same time. Kyoki starts from point -5,9 and heads directly to point 11,1, reaching it in 8 seconds. Nalani starts from point 8,9 and moves towards the y-axis along the line y equals 3/4 x plus 3. Nalani takes twice as long to reach the y-axis as it takes Kyoki to reach the y-axis. Find parametric equation motion for Kyoki, for Nalani, and also how long has Kyoki been moving when the distance between Kyoki and Nalani is as small as it ever gets. Okay, so let's graph this. Okay, so we're going to make xy coordinates and then sort of plot their locations and the paths that they take and go from there. Okay, so let's look at Kyoki. So they start at -5,9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so that's the starting point, -5,9. So I can say that at t equals 0, they are at -5 and 9. So this is for Kyoki. Alright. Then we have point 11,1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. In 8 seconds. So t is 8, they are at point 11,1. Okay, so we can, from this information, we can find parametric equations. Okay, so parametric equations are going to be a set of two equations, like x in terms of t and y in terms of t. And because they're heading like in a straight line, then they're linear. It's like a plus bt, c plus dt. Okay, so if I plug in t as 0, then these are going to cancel, and you plug in x is -5 and y is 9, then you get that a is -5 and b equals 9. So this gives us the value for these. Okay, so let's write what we have now. We have x equals -5 plus bt and y equals 9 plus dt. Okay, now we plug this point in, and that will help us figure out the values for b and d. So b and d are basically sort of like the speeds. There's a Kyoki speed in the x direction and the y direction. Okay, so let's plug these. X is 11, y is 1, t is 8. So we have 11 equals -5 plus 8b. We can find b from here. So 16 is 8b. So b equals 18 divided by 8, which is 2. Cool. Now let's do the same with the y. So we have 1 equals 9 plus 8d. -8 equals 8d. d equals -1. Good. So we go back to here and we plug in the values for b and t. So we have the parametric equations are x equals -5 plus 2t. And y equals 9 minus 1t. Okay, so here is the answer for part A. Keaki's parametric equations. Alright. Okay, now let's look at Nalani. Okay, so Nalani starts at 0.89. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's when time is 0. So let me write that here. Nalani, when time is 0, we have 8 and 9. Okay, so we can start the parametric equation. You can see that if you have the time is 0, these values 8 and 9 are the A and C here. So we have x equals 8 plus bt, y equals 9 plus dt. Okay, so that kind of helped us with the first part. Okay. All right. Then it moves along the y-axis, toward the y-axis along this line. So y equals 3 over 4x plus 3. So slope is 3 over 4, and this is the y-intercept. So the y-intercept is 3. So it's going to hit 1, 2, 3. It's going to hit 0.03, like that. Okay, so we have another point here. We have 0.03, which is a second point that we need to figure out the B and D in here, but we are not given the time. We don't know the time that it took to get there. Okay? So, but they give us more information. So it says that Nalani takes twice as long to reach the y-axis as it takes Keoki to reach the y-axis. Right? So to figure out the time that it takes Nalani, we need the time that it takes Keoki to reach the y-axis. So that's the next calculation that we need to do. Okay, so we're going to go to Keoki's parametric equations, and we say that this Keoki is going to reach the y-axis when x is 0. So we're going to plug in x equals 0 into the first equation. We get 0 equals negative 5 plus 2t. 5 equals 2t. So t equals 5 divided by 2, which is 2.5. Okay, so this is when Keoki hits the y-axis. Now Nalani takes twice as long to get there. So that means that the time with the question that had a question mark here is going to be 5 seconds. Right? Cool. So now we can continue our parametric equations here by plugging in the time is 5 and the x values are 0 and 3. X and y values. Okay, so x is 0. We have 8 plus 5t. So negative 8 equals 5t. 5b. So b equals negative 8 over 5, which is negative 1.6. Alright, let's plug this into the y equation. So 3 equals 9 plus 5d. 3 minus 9 is negative 6 equals 5d. So d is going to be negative 6 over 5, which is negative 1.2. Alright, good. That gives you all the information to find Nalani's parametric equations. So x equals 8 minus 1.6t. Y equals 9 minus 1.2t. Alright, good. We have the answer for part B. Alright, part C. How long has Keoki been moving when the distance between Keoki and Nalani is as small as it ever gets? Okay, so we now need to find the distance between the two people. Alright, so we have Keoki's parametric equations here. We have Nalani's parametric equations here. Okay, so now this is sort of a bit more complex because they're both moving, right? So we want to find the minimal distance, and that particular point in time. So we can't find the minimal distance at different points in time. It has to be at the same time. Okay. So basically, we have Keyaki's location in terms of time is given by these parametric equations. Right. So we have the x value is -5 plus 2t, and the y value is 9 minus t. Right. And Nalani, their location is given by 8 minus 1.6t and 9 minus 1.2t. Okay? We have x1, y1, x2, y2. So we use the distance formula. The distance is equal to x1 minus x2 squared plus y1 minus y2 squared. So we plug these in, it's going to give you the distance as a function of time. So we subtract these. So let's do -5 minus 8 is -13. 2 minus -1.6 is plus 3.6t squared. 9 minus 9 is equal to 0. And -t minus 1.2t gives me 0.2t squared. Let's expand this out. This gives me 169 minus 13 times 3.6 times 2, 93.6t plus 3.6 squared, 12.96 t squared, plus 0.2 squared, 0.04 t squared. Okay, so this equals, add these up, 12.96 plus 0.04 gives me 13 t squared plus 90 minus 93.6 t plus 169. Alright. So we want to find the minimum distance between the two people. Now the distance is this crazy square root, but we can ignore it because if we want to find the minimal distance, you also have to have the minimum square distance. So basically, we can square both sides, and we want to find the minimum value of this. Okay, so just of the story, you can ignore the square root because the only way you're going to have the minimal distance is if you have the minimal value inside the radical, inside the square root. So that kind of makes things a little bit easier. Okay, this is a parabola, this is a quadratic, so we need to find the vertex. So we do -b over 2a, which gives me 93.6 divided by 26. And that gives me 3.6. So this is the time. So the time is 3.6 seconds. So they're both starting at the same time. So Keyaki is starting at -5.9 and excuse me, Nalani is starting at 8.9 at the same time, and they're moving along their lines. So this right here says that 3.6 seconds after they started moving in their respective paths, that's when they're going to be closest. Alright, so that's the answer for part C. But I'm going to just go get a step further and figure out how far they are. So if I plug this back into the distance formula, 13 times 3.6 squared minus 93.6 times 3.6 plus 169. Alright, then that will tell me how far away they are. So 13, 3.6 squared minus 93.6 times 3.6 plus 169 That gives me 0.72. Alright, let's see if this makes sense. Okay, so where are they at 3.6? So let's see where Kiyaki is at 3.6. So if I plug in the t into the x value, -5 plus 2 times 3.6, this is 2.2, and the y value is 9 minus 3.6, which is 5.4. Alright, so 2.2 and 5.4, and this is where Kiyaki is. Alright, now let's look at Nalani at that time. So when t equals 3.6, the x value here is 8 minus 6 times 3.6, which is 2.24. And the y value, 9 minus 1.2 times 3.6, is 4.68. So 2.24, almost the same x value, but slightly lower y value. Alright, there you go. So this is, they're here at the same time. So that is the shortest distance between them. Alright, cool. Alright, the next examples have to do with linear to linear rational functions. So we're going to look at some applications of rational functions that are called linear to linear. So basically this means the general form of these is right here, ax plus b over x plus c. So you have like a linear function and another linear function, you're taking the ratio of them. So you're comparing like the growth of two linear functions. So you only need three constants. You could have like ax plus b over cx plus d, but you could sort of rearrange things, like divide everything by one of the constants, and you can reduce it to like three constants that you need to know. Okay, so in order to solve a model of these kinds of functions, you need to know three pieces of information. So sometimes you know like 3 points on the graph, you're given information about like 3 different values of x and y, like coordinate points. Sometimes you need to know like 2 points on the graph and an asymptote, right? So these, because it's a rational function and the exponent on top is the degree on top is the same as the degree on the bottom, this has a horizontal asymptote. Right, if you ignore these and you simplify a over x, it's going to have a horizontal asymptote at y equals a. So if you kind of know the long-term behavior, it's like for x is large, you have this value, then that value is your a constant, okay? Or sometimes you might know both like horizontal and vertical asymptotes. So basically it's like a combination of like 3 pieces of information that you need to know in order to find these 3 constants, okay? So let's look at this next example here. Client makes extra money selling tickets in front of the Safeco field. The amount he charges for a ticket depends on how many he has. If he has 1 ticket, right, so basically we're going to start making a little table of values to collect our information. So if he has 1 ticket, he charges $100 for it. If he has 10 tickets, he charges $80 a piece. But if he has a large number of tickets, so x is large, I'm going to say x is infinity, then he will sell for $50 each. So this sort of, when it says like a large number of tickets, that's your horizontal asymptote. It's like for long-term behavior, or large values of x, this is your horizontal asymptote, okay? How much will he charge for a ticket if he holds 20 tickets? So the question is, if he has 20 tickets, how much? So this is like the question we need to answer. Okay? So this is it doesn't say it, but this is a linear to linear rational function because you're sort of you have the how many tickets and how the price that is selling. It kind of depends on each other, like in a ratio of sort of way, right? So we want to write an equation of this form: y equals ax plus b over x plus c. Okay, so straight away the large number of tickets is going to sell for $50. This is the a value, so a equals 50, because this is kind of where the horizontal asymptote comes in. Okay, so we're going to plug that in. So y equals 50x plus b over x plus c. Right? If I look at x goes to infinity, these get ignored, the x's cancel out, and you get 50. Okay. Now to do the rest, we plug in the values. So we have 1 and 100. We plug these for x and y. So we have 100 equals 50 times 1 plus b, and then 1 plus c. You want to cross multiply. So 100 times 1 plus c gives you 100 plus 100c equals 50 plus b. And we get, let's put everything, we get 50 equals b minus 100c. Alright, now let's plug in the other point, 10 and 80. So 80 equals 50 times 10, which is 500 plus b, divided by 10 plus c. Cross multiply. 800 plus 80c equals 500 plus b. So 300 equals b minus 80c. So we have these two equations. It's a system. Let's multiply this by -1 and write it under here. So negative 300 equals negative b plus 80c. Negative 250 equals negative 20c. So c equals 250 divided by 20, which is 12.5. Okay, so we found our c value. Now the b value, just plug it into this first equation. So 50 equals b minus 100 times 12.5. 1250. So add, we get b equals 1250 plus 50, which is 1300. Okay, good. So our equation is y equals 50x plus 1300 divided by x plus 12.5. Alright, okay, so we plugged it into here. And now we can answer the question. So how much will he charge if he holds 20 tickets? We plug in x is 20. So 50 times 20 is 100 plus 1300 divided by 20 plus 12.5, 32.5. So 1400 divided by 32.5 gives me approximately $43. Like this. Alright. Okay. Did I do this wrong? Let's try again. 50 times 20 is 1,000, not 100. Haha, sorry. This is where I make most mistakes, right at the end. Simple addition and multiplication. 50 times 20 is 1,000. So 2,300 divided by 32.5 equals $70.77. Yeah, I checked because it didn't make much sense. If it was going, if 10 was 80, 20 should have been smaller, but not that small. Because long term you're selling lots is 50, so you could be selling them for less than 50. All right.